Good people. Let's continue with this beam. Let's draw the shear force. One of the things that we said when drawing the shear force, we said on all given forces, we will draw the vertical straight lines. On all given what? Forces. This is the given force, we draw the vertical straight line. Right. This is the given force as well, we draw the vertical straight line. It's a converted force, we don't draw nothing. It's a given force, we draw the vertical straight line. It's a given force, we draw the vertical straight line. Right. There's a given force there, we'll draw a vertical straight line as well. It's a given force. Right. Then we will represent this beam as a horizontal. This is the beam, we'll represent it. Right. We are therefore interpreting, with the shear force, we are interpreting what's happening on that beam as there's loaded beams and the reactional support. That's exactly what we will be interpreting there. Then one of the things that we spoke about is that when drawing the shear force, you need to start at 0 and end at 0. Then we said we'll be using the number line rules to draw the shear force. We know again that a force, it's a vector, it has two things, magnitude and direction. Now that's the principles that we'll be using here. On this line, we are having a downward force, and all forces going down, all numbers below 0, they are negative. That means here we are having a negative force, and the value of that force, it is what? It is 20 kilonewtons. It is negative. Between this line and this line, there's an extra load on top of the beam, and that extra load, it exerts a downward force, and the value of that force, it is 5 kilonewtons. Now you want to say negative 20 plus 5, it will give you negative 25. Negative 25. Now on this line, we are having an upward force, and all forces going up. Now this upward force, it's counteracting this weight here on the side. And all forces going up, they are positive. Now I'm having a negative 25 plus 41,5. Then I get my answer as 16. What happened now? I get my answer as 16,5. Boom. Can I write it somewhere there? 16,5 newtons, kilonewtons. All right. Between this line and that line, we are having an extra load on top of the beam, and that load is 20 kilonewtons. Now, 16,5 minus 20, it gives us negative 3,5. The fact that there's UDL, we will write it as a diagonal line. Boom. Negative 3,5. On this line, we are having a downward force, and all forces going down, they are negative. Boom. Negative 3,5 plus negative 30 equals to negative 33,5. Now between this line and that line, there's no extra load on top of the beam, there's nothing. Then we will represent this force as a straight line. On this line, we are having an upward force, and the value of that force, it is 63. Yeah? It is what? 63. Now you want to say plus 63,5 because it's going up, it's a positive force. Then our answer there, it is 30. Our answer there, it is what? It is 30. Now between this line and that line, there's nothing. Then we will be representing that force as a straight line. Then on this line, we are having a downward force, and all forces going down, they are negative. You want to say 30 minus 30, equals to what? To 0. You need to start at 0 and end at 0. Now another thing that we spoke about is that where shear force it is 0, that is the indication of your maximum bending moment. Our maximum bending moment, it will be on that point, because on that point shear force it is what? It is 0. This is where our maximum bending moment will be. I will be posting another video as well on how to calculate the maximum bending moment. This is how you draw your shear force diagram, good people. This is easy, straight to